Hi everyone. In this video, I'll give an introduction to object-oriented programming. I first create a class and then I create an object of that class. Now, before I can go ahead and create the class, we need to understand what a class is. A class is a blueprint of an object. That means a class describes an object. In fact, a class describes all objects of that class. And a class defines two parts. It defines the state and it defines the behavior. The state is defined in terms of variables, also called member variables. The behavior is defined in terms of methods, also called member methods or instance methods. Now, the behavior is the functionality, and the behavior oftentimes manipulates these variables or operates on these variables. So when we define a class, we describe what all objects have in common. All objects will have these variables and all objects have these methods. Or to be more precise, every single object of this class will have a set of these variables and will have these methods. Now let's go into an example. Let's say we want to create a class that represents a car. First, we need the class keyword followed by an identifier. In this case, my class should represent a car, so I just name it car, followed by a code block. Now this follows a naming convention. It follows the Pascal case naming convention. It's just like camel case, but instead of a lowercase letter, it starts with an uppercase letter. Another note, every class is mostly or typically defined in its own file. So there's a single .java file for every class that we have. And when we write a class in a single Java file, typically there should be the public keyword in front. But for now, just to demonstrate it, this is totally fine, and I keep it just with the class and the identifier. Now let's move on. Let's define the state of a car. In my example, the state will have two variables. It will have a Boolean variable, is lights on, and it will have an integer variable that represents the speed of a car. Here I follow the naming convention with is. So Booleans typically start with is or has. Now these are member variables. Member variables are kind of like global variables that every object of the class has. And member variables always have a default value. The default value for Boolean is false. Here, the default value for an integer is 0. So based on the type, it always uses the default value of the type. But I'm still free to initialize this. So if I want to initialize this explicitly or to a different value, I can do so. Now, when we define a state, always focus on what you need in your program. Don't think in general what a car has and put all possible variables that you can think of in. Really focus on what is needed in your program. With the state complete, I now move on to the behavior. Like I said, the behavior is defined in terms of methods. And the first method here I create is called turn lights on. This will simply set the Boolean variable is lights on to true. And then I output a message. Lights are on. Now I create another method called turn lights off. This will simply set it back to false. And here I output a message. Lights are off. Now I also want my car to be able to speed up and slow down. So I express this in two more methods. First is called speed up, and I pass in a certain speed that I want to speed up to, and then here I set my speed to that mph. And then I add another method called break. This simply breaks. And what I do is I subtract 10 from the speed. And then I have a safety check. If speed is less than 0, I set the speed to 0. Now all these combined, I add with all these, I'm pretty much done with defining the behavior. Now I add one more utility method called public string to string. This is very common in Java, and what this will do is it will provide a string representation of my class. And this is not outputted to the console, it is always returned. So here I return car, and car has a speed, which is defined by the speed variable, and it has is lights on. This is defined by the is lights on variable. So this is really just creating a string with string concatenation with these two member variables appended, and it concatenates it and returns it. This is really highly recommended that you do this for every class. And it is called toString. Now I leave it at this and go one more time over what we have. We have a state with 2 variables. We have behavior with 4 or even 5 methods. Now this is still code that is never run, it's never executed. We cannot even call these methods at this point. We need to have an object. And when we create objects of the class, then we can call these methods. Now you can view this as a blueprint. It's a plan how to build an object. So if I simply give you a plan, based on the plan, you cannot drive the car, you cannot speed up, you cannot do anything on the car. At this point, you only have a plan. But with that plan, we can follow the plan and create an object. So this is what I do in the class here. I have car. I call this car1. And this is how I declare it. It's pretty similar to the primitive data types, the variables that we had, data type and identifier. Now with this, I don't have an object yet. I simply have a variable that can reference an object. Now in order to create a new object, I need to call new. New creates a new object. It allocates memory, and followed by that, I can write the class name and open closed parentheses. So this is called a constructor. I explained that in a separate video, but this is just a class name, kind of like written as a function. This creates a new object. Now we have an object. And what we can do now is call methods on that object. For example, turn lights on. Or if I want to, I can turn them right back off. Turn lights off. Now let's run this program. This program starts at the main. It creates a new car. It calls turn lights on. So if we go to this method, it sets the Boolean variable of that object to true, calls lights are on. This is what we see here. Goes back to the main and then calls the turn lights off method, sets the variable to false and outputs it. Now you notice that I call this on the object. In fact, if I use the car and try to call it, I don't get any suggestions, and if I really type it in, I get an error. I cannot call these methods on the class. I really need an object for it. Now that I know that the class is a blueprint, I can use it to create as many objects as I want. I can create another object here. For example, car2 equals new car. And now I have a second car. And let's say I use this car2, turn the lights on, and then I want to speed up. So I speed up to 50 miles an hour. Now let me output both cars. Car1, and here notice what I can do now. I simply pass in the object here. And then I call car2, and pass in the second object. So I don't need to call any properties. When I use string concatenation with an object, it will call the string toString method. And we'll call this and return the string here. So every time I want to output it, I can keep my code very clean. Now when I run this, what we'll see is that we have the first car, which is a car still stopped, speed is 0, and the lights are off because I turned them right back off. The second car, however, is driving at speed 50 and the lights are on. So what we see here is that each object has its own set of variables. The first car has speed and lights on, and the second car has speed and lights on. And the more objects I create, the more of these variables exist, because every single object will have a set of these variables. Now I hope you enjoyed this video, and I highly recommend to create your own class, play around with it a little bit, create some objects. This takes some time, especially in the beginning, to get used to, but I hope this is enough to get you started. Thank you for watching.